Okay, let's look at multiplying binomials. We're going to use the FOIL method to multiply these binomials. Remember, binomials means two terms. So the FOIL method, what does that mean? FOIL is an acronym. It stands for first, outer, inner, and last. So that is the order that we're going to multiply these binomials in. First, outer, inner, and then last. So let me show you what that means or what that looks like. So let's start with an easy one. X plus 2 times x plus 3. So remember the FOIL method, first, outer, inner, last. So what that looks like is when I multiply the first terms together, I'm talking about the first terms in each set of parentheses. So it's the x times the x, and I usually use arrows to help me do this. X times x is x squared, because we add the exponents, 1 plus 1. And then we get to the O, which is outer terms. The outer terms are the ones on the very outside, so the first of the first parenthesis and the last of the second. Those are the outer terms. So x times 3 is written as 3x. Next is inner. The inner terms are the ones on the inside. 2x, 2 times x is simply written as 2x. And then my last term. That is the last terms in each set of parentheses, so the 2 and the 3. So 2 times 3, which is a positive 6. All right, so I'm done multiplying. I do have one extra step at the end, and that's to combine any like terms that you might see. Here I see a set of like terms, the 3x and the 2x. So my final answer will be x squared plus 5x, because 3x plus 2x is 5x, and then bring down that constant of 6. So that is how you multiply binomials using the FOIL method. Let's do a couple more examples. All right, let's try number 2. 3x plus 2 times x minus 5. So first terms, let's do the 3x times the x. 3x times x is 3x squared. Now let's do the outer terms. On the very outside is 3x and negative 5. 3x times negative 5 is negative 15x. Now those inner terms, the 2 times the x, which gives me a positive 2x. And then the last terms, 2 times negative 5 is negative 10. Done multiplying. Now let's just combine. And these like terms are conveniently in the middle when we do our FOIL method. Typically the two middle terms will be matching. So bring down that 3x squared, and then that negative 15x plus 2x is negative 13x, and then bring down that negative 10, and that is my final answer. All right, so let's look at a couple special cases. Here, just following those same steps of FOIL. So the first terms, x times x, is simply x squared. The outer terms, x times negative 5, so negative 5x. The inner terms, positive 5 times x is positive 5x. And the last terms, 5 times negative 5 is negative 25. Combine like terms, so those middle terms, negative 5x and positive 5x. So what do you notice about that? Negative 5 plus 5 is 0. So these go to 0. So I'm just left with the first term, which is x squared, minus 25. So the first term and the last term. So when those two middle cancels out, we're left with a special kind of binomial. and it's called a difference of perfect squares. The difference of perfect squares, it's a special term we like to use. It'll be really important. You'll hear it a lot when we do our factoring, but it simply means a difference because it's subtraction. And then perfect squares because x squared is a perfect square and 25 is a perfect square because it's 5 times 5. So the special name for that is a difference of perfect squares. Let's do one more example like that. Okay, so notice just like number 3, what makes this a special case is because it is the sum and the difference of the same numbers and the same variables, the same terms, 2x and 2x and 4y and 4y. Just one is a sum and one is a difference. So when you have a problem that looks like that, that middle term is always going to cancel out. So when we do our FOIL method, first, which will be 2x times 2x, gives us 4x squared. And then outer for O is 2x times negative 4y, which is negative 8xy. Don't forget about the x and the y when you multiply. Inner terms, positive 4y times positive 2x gives us positive 8xy. And then last, positive 4y times negative 4y is negative 16y. When you go to combine those like terms, negative 8xy and positive 8xy, that gives me 0, so those cancel out. So I'm simply left with 4x squared and negative 16y as my final answer. Oh, I'm sorry, that's supposed to be y squared. When we did the positive 4y times negative 4y, that's negative 16y squared. That should have a squared attached to it. So again, that is called a difference of perfect squares. It's just a special case, but you're still just following FOIL. Let's look at one more special case. All right, so this one looks a lot different. X minus 3, that quantity squared. So that looks a lot different, and I only see one binomial instead of 2. But remember, square just means repeated multiplication, so I can rewrite this problem as x minus 3, the quantity, times the quantity of x minus 3. You just write it out twice. That's why that 2 is there. And then I simply follow FOIL, first, outer, inner, last. So first will be x times x, which is x squared. And then outer is x times negative 3, so negative 3x. Inner, negative 3 times x, negative 3x again. And last, which is negative 3 times negative 3, which gives me a positive 9. Combine those middle terms. Notice this time that they match, so they don't cancel out. I just double it. Negative 3x minus 3x will give me negative 6x. Bring down that plus 9, and that is my final answer. So this has a special name. When the problem looks like this, the answer has a special name. It is called a perfect square trinomial. Okay, and it is a perfect square trinomial. It has 3 terms, which makes it a trinomial. And it's a perfect square because it's the result of x minus 3 squared. Let's do one more like this and we will be done. Okay, number 6. So remember, if you see one written like this, first you need to rewrite it. I'm going to rewrite it as 2x plus 4y times 2x plus 4y. Just be really careful there. Don't forget. Then I just simply FOIL. First, outer, inner, last. This one was a little bit harder, but not too bad. First is 2x times 2x, which is 4x squared. Remember, you multiply the coefficients and add the exponents. Then you do the outer terms. 2x times 4y gives me a positive 8. And then don't forget about your x and your y. Okay, now let's do my inner terms. 4y times 2x gives me 8xy again. And then the last terms, 4y times 4y, which is 16y squared. Combine those middle terms, which match, but bring down that 4x squared, and then my 8xy plus 8xy is 16xy, and then bring down that last term, 16y squared. That is your final answer, and again, that's called a perfect square trinomial because it's the result of 2x plus 4y squared.